Hello everyone, welcome back to this channel. So in this video, we are going to talk about how to achieve high availability in a scalable system, okay? So we will mostly focus on replication. So if you go to our very first two videos, we talked about the properties of a distributed system, right? The first one is high availability. The second one is high scalability, and the last one is high reliability, right? So in the availability video, we talked about how to achieve high availability, right? Which is through multiple machines. And we talked about multiple ways to do that. One of them is through replication, right? So basically, you replicate the data on multiple machines, right? So in this video, we are going to talk more about this replication mechanism to achieve high availability in a system, okay? And also, if you remember what we talked in last video, we talked about the consistent hashing to achieve high scalability, right? So what is consistent hashing? Basically, you make all your machines in a ring, right? And you just distribute different requests to different machines based on the hash of the data, right? So for example, maybe data which is hashed to 26 will be distributed into machine 1, where it's responsible for data between 20 and 39. So for a request whose hash can be 62, then machine 3 will be the machine who will host this data, right? Because it's responsible to store data whose range is in 60 to 79. So this is consistent hashing, right? We also talked about one point, which is, let's say if machine 2 goes down, its data will be moved to the next machine in the ring, right? So basically it means if machine 2 goes down, its data, which is 48, now it will go to machine 3. So now machine 3 will be in charge of machine 2's previous data. So this means machine 3 now will be responsible for 40 to 79 range data, right? So one question people will ask is, if machine 2 already goes down, it means its data cannot be retrieved anymore, right? So how can its original data C, whose hash value is 48, can be moved to machine 3, right? So how? So that's what we are going to talk about in this video, okay? So basically that's an availability issue, right? Which means the data should be available, always available to be used, right? So you cannot lose data, right? Okay, so let's copy this so we can talk more about it in this video, okay? So I copied it here, okay? Cool. Let's remove these numbers to make it more concise. Okay. Okay, cool. So to achieve high availability, you must, which means the data cannot be lost and the service should always be online to serve requests, right? Especially for the data. If you want to not lose any data, it means your data cannot be on a single machine, right? It must be on multiple machines. So if we store the same data on multiple machines, then it's called replication, which is a topic of this video, okay? Okay, so now let's say we still have this same hash ring, okay? Which means when a new request comes, let's say this is a new request, when a new request comes, it should be routed to one of these machines, one of these 5 machines, right? So let's say based on the consistent hashing algorithm, it will be served by machine 1, okay? So this data will be stored on machine 1, or this request will be served by machine 1, okay? And this is a new request, okay? Cool. This new request or new data will be stored on machine 1, right? So to achieve high availability, you must store the data on multiple machines. So actually for this machine 1, it's actually a group. It's not a single machine. It should be a group of machines, right? So here, let's say we have 3 machines as the group, which is called group 1, okay? So this new data will be written to all these 3 machines. So we replicate the data on 3 machines. So even if 1 or 2 machine goes down, we still have 1 or 2 more machines to serve the data. The data will not be lost. This is how we achieve availability through replication, right? So now there will be 2 problems or 2 questions if you think more about this, right? The first question, okay, let's see. Question 1. Which machine in the replication group should serve the request or store the data? So let's say this is a new data request, okay? So this is a new data request. Maybe it's a write request or maybe a read request. So let's assume it's a write request, right? So, okay, it's a request. A request can only be sent to 1 machine, right? So it must hit 1 of these 3 machines, right? So the question 1 is which machine this request should be sent to, okay? So so there are 2 modes, or there are 2 mechanisms we can use to do this. So let's say, yes, the request will go to group 1, okay? So let's say in group 1, we have these 3 machines, okay? Okay, cool. So to solve this problem, there are 2 modes, or there are 2 solutions. Solution 1 is master slave mode, okay? What does this mean? It means one of the machines, let's say it's this machine on the top, it will be master machine. And the other 2 machines are slave machines, okay? So when a request comes, it will always hit the master machine. So to be more exact, when a write request arrives, it will always hit the master machine. So when the master machine receives the request, it can send another 2 requests to the other 2 slave machines to store the data. So that's how we can do replication, right? So it's a master machine who will do the replication. So all the writes will always hit the master machine, right? And the master machine will send additional requests to the slave machines to store the same data on the 2 machines, okay? So this is a write request, okay? And for read request, it should also hit the master machine, okay? So for read request, so every operation needs to go through this master machine, okay? So this is called master slave mode. Okay, another solution we have is called master mode. Solution 2, okay? This is called master mode. What does it mean? It means there is no difference between these machines. They are all masters. Let's say we still have the 3 machines. So for a write request, let's say for request 1, okay, I can just hit, let's say it's a write request for write 1. I can just hit this machine 1, okay? And for another write request later or at the same time, it can just hit a different machine. So the request can be sent to any of the machines, okay? So there's no difference between these all these machines. The request can be sent to any machine. So this is called master mode. Okay, so still similarly to master and slave mode, if this machine 1 receives a write request 1, it will also send additional request to the other 2 machines. Similarly, for machine 2 here, when it receives the write request, it will also send 2 additional requests to machine 1 and machine 3 to achieve replication, right? So this is called master mode. So this is a first problem, right? Or first question and its solution. Okay, now we also have another question, which is, should we use sync mode or async mode for the write? What does this mean? Okay, so let's copy this, okay, here. So no matter if we use master slave mode or master mode, there could be 2 modes we could use. One is sync mode, one is async mode. So for sync mode, it means, let's say for a write request, when a write request arrives for the master slave mode, okay, yes, the write request will hit the master machine, right? So for sync mode, for sync operation, it means, okay, for this write request, I must wait for the 2 additional write requests, which is sent from the master machine to the other 2 slave machines. I must wait for these 2 machines to finish, and then I can respond back to the client to say, okay, the write succeeds. So this means all the 3 machines has to accept the data and acknowledge that, oh, I received the new data. All the 3 machines have to acknowledge the acceptance of the data. Then we respond to the client for the succeed of the request, right? So this is called sync mode, okay? And in async mode, it means, okay, so when a write request comes and, oh yes, it hit the master machine, right? Okay, then after master machine writes the data to its own storage, it immediately responds back to the client to say, yes, now the write succeed. And then it sends the other 2 requests to the other 2 slave machines to store the same data. So you can see in this case, in this async mode, only the master machine accepts and acknowledges the data is accepted, right? So even the data is not written to the other 2 machines yet, we just respond back to say, okay, the write succeed. This is called async mode, right? So for sync mode, which is all 3 machines must acknowledge the data has been written. What's the good things about it, right? Yes, the good things about it is it's very, very high consistency, right? There will definitely be no data loss. It's a very, very high consistency, which means the data will always be the same on all the 3 machines, right? On all the replications, right? So which is very good. Data will never be lost until all 3 machines die, right? So this is the benefits of a sync mode, right? And what is a downside of this sync mode? Yes, if you use this sync mode, it means availability will be very poor, right? Because we have to wait we have to have the data to be written to all the 3 machines. Then we can acknowledge, okay, the write is successful, right? So let's say now 1 machine goes down. Then you cannot perform write anymore because you must use all 3 machines to have the write succeed, right? But if 1 machine goes down, then you cannot accept writes anymore. You can only accept read, right? Okay, so this is the downside, right? And also another downside is performance, right? Because you have to wait for the writes on all the 3 machines to succeed. it means the latency of this write will be very long. So we have maybe a poor performance, right? Okay, so this is the sync mode. So what's the benefits of async mode? Yes, for async mode, it's very fast, right? The write is very fast because you just write the data to the master machine, then you respond back, right? So the performance is very good. You don't need to wait for the other two machines to accept the write. However, the consistency will be very poor because when you tell me the write succeed, actually only the master machine has the latest data. So the data on the master machine is different than the slave machines, right? And there could be also data loss. So for example, let's say master machine accept the writes, and then it acknowledge to client to say, oh, now I have the data. So the write is successful. And then before it sends the to request to the slave machine, it dies. Then it means the slave machines, they don't have latest data about this write anymore, right? So the data is lost. So that's a downside of async mode, okay? And this brings out a very famous theory, which is called cap theory, okay? So what is this? Cap is actually, they have three words here, right? So it is, C means consistency, okay? A means availability, and P means partitioning. Okay, so what does this mean? Okay, so consistency means, okay, after I write a data to your system, later when I read the data, I must get the latest data which I wrote before. So let's say I write data 10 to the system. Next time when I read the data, I must get the number 10 rather than old number, which could be 8 or 7, right? So this is consistency. Availability means, okay, the system should always be available, right? So when I send you a request, you must be able to return me some response without error. This is availability. Last one, partitioning. Partitioning means, partition means there is no partition in my network, which means, so basically a simple example is that there will be never case where machines are going down, right? So let's say we have 3 machines in our system, so all of them should work. So all of them should be connected together. There will be no machine dying, there will be no disconnect between their networks, right? So this is called partitioning. Okay, so what is cap theory? Cap theory means out of these 3 properties, consistency, availability, and partitioning, you can only have 2 of them at most. So what does this mean? Okay, so let's make it simple. Okay, so partitioning, this is something you can definitely not achieve, right? Because you will always have machine dying, and you will always have network disconnect, right? So these physical conditions you cannot control because that's a natural of network, right? So for partitioning, yes, you must. So partitioning, we must have it. So which means we must allow partitioning, right? So this cannot be avoided. So that means based on this theory, you can only have 3 of them, right? You can only have 2 of them at most. So now partitioning, yes, you cannot avoid. So you should tolerate partitioning, right? So now we only have C and A. So between C and A, based on the theory, you can only have 1 of them now, right? So now you can either have consistency or you can have availability. You cannot have both of them. Okay, now let's go back to our example here. Okay, so let's say we have replications, right? So we replicated the data among these 3 machines, right? Okay, So let's say if we have consistency, okay? So based on our previous example, it means, yes, I will write data to all these 3 machines, right? Okay, so which means whenever I send a write request, I must wait for all the 3 machines write this latest data, and then I can respond back to say, okay, the write is finished, right? So this is how we achieve consistency in our previous example, okay? Yeah, but in this case, you cannot achieve availability, right? Because your requirement is that all the 3 machines must write the data before complete the whole request, right? So as long as one of them goes down, you cannot finish the write anymore, right? So this means you don't have availability, right? So let's say, yeah, one machine goes down or one machine disconnect with other 2 machines, then you cannot accept write request anymore, which means your system is not available now, right? So once you want to have high consistency, you cannot have high availability now, right? And on the other hand, if you want to have high availability, you cannot have high consistency. So let's still use the same example, okay? So high availability, so let's say we still want the request to be replicated among all the 3 machines, right? Okay, so let's say I want to have availability, which means, okay, I want the system always be online, right? Okay, so you want the system always be online, which means you could allow some of the machines, even some of the machines goes down or disconnect with other machines, the system should still be able to process my request, right? So in this, let's have an example, okay? So let's say these 2 machines, these 2 slave machines went down, right? They died, okay? So we still want to serve the request, right? It means this master machine should still be able to accept the request. So once it receives a write request, I must be able to respond to the client and say, okay, the write is successful. So in this case, the data is only written to the master machine, right? But this cannot achieve consistency, right? Because the data has not been replicated on the other 2 machines yet. So let's say the other 2 machines recovered, but this master machine suddenly died, okay? So then one of these 2 slave machines will be promoted to the master machine, right? So in the future read request will come to the one of the slave machines, right? However, the slave machines don't have the latest data which you have written to the master machine before. So then we return old data to the client, right? So this causes inconsistency. So in this case, yes, you do have high availability, which means, yes, I do want to serve requests continuously. Even some of the machines died. But it means you cannot have consistency. It means you can return stale data in many cases, right? So this is the cap theory. Cool. Okay, let's go back to the async mode and the sync mode. So can we have so we know both of the sync mode and async mode, they have their benefits and they also have their drawbacks, right? And also based on the cap theory, you must have a balance between consistency and availability. Right? You cannot achieve both consistency and availability. So how can we combine the benefits of the sync mode and async mode so we can still have a good system? Okay, so here, let's see, how can we combine the benefits of sync mode and async mode?